Okay, hey everybody. Welcome to our presentation today. I'm glad that you're all here and glad that we can talk about our PHP SDK and also Amazon DynamoDB and how you can use them together effectively and also take advantage of some of the built-in features of the SDK. My name is Jeremy Lindblom.
Hi, and I'm Michael Dowling. Jeremy and I are software engineers on the AWS Developer Resources team, and we work on the software that helps PHP developers connect with AWS.
So I'm curious, how many of you here are actually PHP developers? Let me see a show of hands. So that looks like a good number of you. That's awesome. I'm glad that you are here and that the rest of you who aren't PHP developers, I'm glad you're here too. So don't feel left out. We're going to take a look at some PHP code examples today. So if you're not a PHP developer, you can ask someone who next to you who raised their hand, ask them questions afterwards. As you may have seen, earlier this year, we released a new service, Amazon DynamoDB. How many of you have had a chance to play around with that or use it in your application? Cool, so that's a few of you, and hopefully after today, maybe some more of you will give it a shot. Also, at the beginning of this month, we released a brand new version 2 of the AWS SDK for PHP. And so today, as we go through our code examples, we're going to be using code examples from that version. Just out of curiosity, has anyone here taken a look at that yet? Cool. If you want to come talk to us afterwards, that would be great because we would love to get some feedback. So if you want to just meet in the hall sometime, that'd be good. Was there anyone over there that raised their hand too? Cool. All right, you too. And what about SDK, the version 1 of our SDK? Who's been able to use that? So more of you. So what you're going to see is you can see some things that are similar and a lot of things that are different, and hopefully you'll be able to see some of those differences and get an idea for what the changes are. So before we get too deep into our presentation, we're going to talk about some of the basics of our new SDK and of the Amazon DynamoDB service. But I'm going to go ahead and let Michael talk to you about the SDK. Not only is he one of the main developers of the new SDK, but he's also the author of the Guzzle HTTP library, which is used as the foundation for the new SDK.
Thanks, Jeremy. So, AWS has offered an open source PHP SDK for a few years now, and since the creation of the SDK, we've seen AWS's service offering grow significantly, and we've also seen a shift in PHP and the PHP community itself. And so with that, we've decided that we would rewrite the SDK from the ground up. Yeah, thank you. All right, let's try that. So you may have seen something interesting recently. It's that the SDK was rewritten, and here's a picture of the GitHub page. And we rewrote the SDK in response to customer feedback. And that feedback was that performance is becoming more and more critical for applications. So as people are using our SDKs in front-end systems, so like to power your sessions with the DynamoDB session handler, you need that to be as fast as possible. And we also got a lot of feedback that people need flexibility. So we know that every use case is unique. So what we've done is, based on the Guzzle framework, it's completely event-driven. So you can add and remove behavior as needed. So for performance needs, you might want to remove some sort of helper. And then you can also add functionality that might be specific to your use cases. There's also more high-level abstractions. So you may have needed to iterate over a paginated resource. And doing that, you needed to know what the next token was and how to send a subsequent request until finally you exhausted that list of paginated data. So we've added iterators, and also we've added batching functionality. So now you can send items to a batch object, and that will, in the most efficient way possible, send up bulk operations for you in parallel to do a very efficient processing. Our SDK is also more open source. So we're using and contributing back to open source libraries. Instead of reinventing the wheel where it wasn't needed, we're benefiting from existing work and focusing on the things that are more important, and that's providing a good customer experience for our SDK. And finally, one of the things that's very important is that we're publicly shipping our unit tests. So this helps to take a lot of the guesswork out of pull requests and additions to the SDK. So you can have confidence in your submissions. And also that's going to help drive quality up over time because it's going to help prevent regressions. So anytime a bug is reported, we'll create a unit test, and then that will ensure that that never happens again. So with all that feedback, we decided to rewrite our SDK on top of Guzzle. As Jeremy mentioned, Guzzle is a PHP HTTP client and web service framework that I started a few years ago. And it provides the foundation of the SDK. So it provides the iterator abstractions, batching. It provides a service locator. And then there's also various plugins that you can use with Guzzle clients and, in turn, our SDK. Plugins like caching. So say you need, your application can serve stale content. So you could cache that using the HTTP plugin. There's over-the-wire logging plugins, so that's helpful for debugging to see exactly what bits are sent over the wire. And so the glue of Guzzle and the glue of our SDK is actually the Symfony 2 event dispatcher. And that is a component from the Symfony 2 framework. And it allows you to build applications that are decoupled without having to subclass. So you can attach observers that listen to specific events that are emitted from a dispatcher. And then that observer can do behavioral modifications to the context passed to it. So this is prevalent throughout our SDK from the ground up, from client objects to HTTP requests to iterators. So now that we've covered a little bit about the SDK, let's dive into a code example to show you kind of how to get started. And if you look at the top line, you might notice that the new SDK, you have to require an autoloader. And we're using a PSR0 compliant autoloader powered by Composer. And if either of those terms are new to you, don't worry, we'll cover both those in just a second. So Composer provides this vendor autoload class, and we'll require that. And then in the next line, you see that we're creating a service locator, AWS common AWS. We're using the factory method. We're passing in an array of configuration options. So these options are going to be shared by the service locator to every client created from it. So we're passing in our key, secret, and a default region that we're going to use. You only have to define this once, and this is going to be shared throughout. And alternatively, rather than passing in an associative array, you could pass in a file, the path to a file, a JSON file that basically has the same keys, and it's just in a JSON format if you want to load from disk. So here we are creating a DynamoDB client by calling the get method on the service locator and passing in the name of the client. And then we're calling S3, we're getting an S3 client. And both of these are going to use the same credentials and region. And the thing to keep in mind with the service locator is that each subsequent call to retrieve the same client will return the same instance of that client. So it kind of shares that so you don't have to recreate it over and over. But if, for example, let's say you wanted to create a one-off client that didn't need to be persisted globally in the service locator, you could pass an optional argument of true to the service locator to kind of create a throwaway. So I mentioned PSR0, and that's actually a coding standard recommendation from the PHP Framework Interop group, or PHP FIG. And FIG is a group that is trying to make sharing code between projects as friction-free as possible. And in doing so, they want to remove some of the minor differences like coding standards and auto-loading. And some of their overarching goals are things like defining common interfaces for things like logging and caching. So the new SDK is actually implementing PSR 0, 1, and 2. And PSR 0 is an auto-loading coding standard that it defines how the path of a file is mapped to the namespace and where on the file system that class lives. So by adhering to that, we can use a standard autoloader like the one provided by Composer. And PSR 1 is a pretty basic coding standard, and PSR 2 is a more in-depth coding standard that defines just about everything about the style of your code. And this as well as unit tests, this is going to help take guesswork out of submissions, so there won't be back and forth on like CS fixes. And we think this is going to help to make a more consistent code base because you adhere to this pretty generalized standard, and it's going to help also with the quality over time as well. So I mentioned Composer, and that might also be new to some of you. Composer is a fairly new dependency management system for PHP, and it's for application-specific dependencies. So like whereas you probably used Pair before, Pair is like a global dependency installer, whereas Composer is per application, and it's not really global in that entire system. So all you do is you call composer.var install, and that's going to go out and grab all the dependencies of our new SDK, pull them all into the vendor directory, and create an autoloader for you. And that's what I showed earlier, where you just include vendor autoload.php. And another cool thing about Composer is if you want to squeeze even more performance out of your application, you can create a class map autoloader. And this is basically a hash of a class name to where on disk that class lives. So that's great for production environments, so check that out. And you can learn more about Composer at getcomposer.org. So with all of this, we're using some great new open source projects, and it's helping to power our SDK. And we think it's going to make you more productive when you're utilizing our web services. So now that we've told you a little bit about the new SDK and some of our motivations for rewriting it, I'm going to let Jeremy tell you about Amazon DynamoDB.
Thank you. So like I said earlier, Amazon DynamoDB is a new service as of this year. And it's actually the fastest growing service we've ever had at AWS. Amazon DynamoDB is a fully managed NoSQL database solution. So I'm expecting probably quite a few hands here, but who's has experience with working with NoSQL databases? Okay, that's what I expected. So they've been gaining popularity over the last few years, and for a lot of good reasons. One of the reasons I think that they are particularly important is that they are a lot easier to scale than I think traditional relational databases. You'll find that's true with Amazon DynamoDB as well, and even more so. DynamoDB is a fully managed database solution, and it has a unique concept of provisioned throughput. Now, provisioned throughput is essentially the number of read and write operations you can do per second, per table, per kilobyte of data. So that was a lot of pers, so I'm going to go back and say that one more time just so you catch them all. It's the number of read and write operations per second, per table, per kilobyte of data. So for example, if you are writing a database item to DynamoDB that's about 2.5 kilobytes in size, that's going to be rounded up, and it's going to use 3 units of your provision throughput. So in the DynamoDB documentation, you'll see references to write capacity units and read capacity units, or WCUs and RCUs. Those are the units of your provision throughput. And you can adjust those independently on your table for either read or write heavy tables. You can adjust both of them independently. I have a picture of a dial on the screens because to me that represents how easy it is to change your provision throughput on a table. It's just like turning up or turning down a dial. You can scale up or scale down very easily. And the best part about it is that it's completely seamless. Your database has no downtime when you are adjusting either up and down. So, like I said, DynamoDB is a fully managed service on AWS. So AWS handles all the hardware, software, maintenance, and all that, so you don't have to worry about that like you do when you're trying to host your own database. So one of the other cool things is that your data is automatically replicated for you. So when you write an item to DynamoDB, you don't even get a response back until your data has been replicated into at least 2 availability zones. So you can ensure that you have more reliable data. DynamoDB is also designed to be fast. The data that you write to DynamoDB is stored on solid-state drives to reduce the I/O latency. And that can speed up the performance of your application. And also with the concept of provision throughput, you have a very predictable performance as you are controlling basically how fast you can write to your database. So we've talked about the SDK, we've talked about DynamoDB. Let's talk about how we can use them together. To do that, we're going to look at a fictional use case about building a web application for an animal clinic. So we're all going to work together to build this application. So the website that we're going to make, we can have pet owners log on, register on the website, create and update pet profiles, and also schedule appointments to see the veterinarian and also get notifications back. To solve some of our immediate scalability concerns, we can host our application on AWS Elastic Beanstalk. Elastic Beanstalk is one of our high-level services that encapsulates some of our other services like Amazon EC2, Elastic Load Balancer, and autoscaling. So that makes it easy for PHP developers to deploy their application on AWS architecture and have it be immediately scalable with very little configuration. So using Elastic Beanstalk, we can set up our application in Elastic Beanstalk, and as our animal clinic grows and we get more traffic, that scaling is going to happen automatically with little or no effort on our part. We'll also use Amazon DynamoDB to store our pet profiles and appointments. So One of the challenges that we face as developers is when we go from a single server application to scaling out to multiple servers. There's always some rough edges there. And so with Elastic Beanstalk, we avoid some of those rough edges by hooking into AWS architecture. But one thing that you might not remember to do or worry about is how you're scaling your session storage. So if you don't implement that correctly, you're going to have visitors come to your website, log in, maybe make it to another page, and then get redirected back to the login screen over and over again. And that's not what we want to have happen. And that happens because the native PHP session handler stores its sessions on the file system of the server. So as soon as we scale up to multiple application servers, we have our session storage fragmented across different servers, and it's not accessible to the other servers in the cluster. So you have a lot of people that are going to start calling you and saying, hey, I can't use the website at all. That's bad. So in the SDK, we provide a feature called the DynamoDB session handler, which allows you to use DynamoDB as your session storage. This provides a global area to store your sessions accessible to all the servers in your cluster. And also, you gain all the benefits of being hosted on DynamoDB, which we just talked about. The DynamoDB session handler is meant to be a drop-in replacement for PHP's native session handler. And that's because it's implemented using PHP's session set save handler function, which you can use to register callbacks to handle the session functionality that hooks right into PHP's native session functions. And it's very easy to set up. Using the service locator that Michael showed you in his code example, we're going to get a copy of the DynamoDB client and then call the register session handler method on that. And there's a lot of options you can pass in to configure it, but here we're just going to show, I'm just showing that you pass in the table name of DynamoDB, so you can either create that table through the SDK or through the AWS console, and just pass in the table name, and your session handler is all hooked up. After that, you can use PHP sessions just like normal. You can all the native PHP functions like session start, session destroy, session write close. You can work right with the session superglobal, and it'll all read and write to DynamoDB for you behind the scenes. So with something that easy, it's kind of hard not to smile about it, right? So I want to also cover a few of the best practices with the session handler. One, you should set an appropriate region for your DynamoDB table. And by appropriate, I mean it should be as geographically close as possible to where you're hosting your application to reduce latencies. So in our example, where we're using AWS Elastic Beanstalk, let's say we created our application in the US West 2 or Oregon region. We'd want to create our DynamoDB table for our sessions in that same region. Second, you should set and monitor your provision throughput carefully. And I have that picture of the dial again to show you how easy that is. And basically, you just need that value is going to be completely application specific and also dependent on the amount of traffic you have. But you can change it at any time. And you can create your DynamoDB table and hook it up with CloudWatch. If you use the AWS console to create your table, you have an option right there to hook it up to CloudWatch. But you can monitor the usage of your provision throughput and set alarms or even programmatically react to that. So if you're using 90% of your provision throughput, you can change your table configuration to increase that. Or if you're not using very much, you can change it to adjust that back down. So you only have to pay for what you're going to use, and you can use that monitoring to help you with that. Third, you should try and keep your sessions small. And this is a good practice no matter what kind of session handler you're using, because that's going to keep your application running fast. But as I told you with the provision throughput, it's read and write operations per second per table per kilobyte of data. So if your sessions are larger than a kilobyte, that actually uses more provision throughput. So under a kilobyte is better, both for managing your provision throughput and also for speed. Fourth, you should schedule your session garbage collection as a separate process. Does anyone have an idea of how the normal session handler or the normal session garbage collection works? Has anyone ever looked into that? It's pretty interesting, isn't it? There's two INI settings that basically make a probability of the session handler or the session garbage collection being triggered. And so a random visitor to your website, well, it might just get hit with the cost of doing your session garbage collection, and you don't want that to happen, especially if you're making web service requests to clear out your tables. So it's better to schedule that on an off-peak time for your application using a cron job or some other scheduling mechanism and trigger the garbage collection that way. So that's the session handler, and using that, we keep our visitors to our website logged in. And Michael's going to talk about how we can use the SDK and DynamoDB to solve some of the other challenges we might have.
Thanks. So in our use case with this animal clinic, if there were something like a pet virus outbreak or something, then the site would scale up a lot because everyone would be just trying to sign in, register their pet, schedule an appointment. So now that we're using the DynamoDB session handler and people can stay logged in, there's no issues. We've got a ton of data in our tables. And so this animal clinic might try to vaccinate the most at-risk animals first. So we've got all this data, but we need to pull out only a subset of the animals. So here's some of our criteria. We got puppies, kittens, old dogs, old cats, and hefty cats. And so before we dive into our actual scan filters and criteria that we'll use, let's take a look at our schema that we're going to work with and some example data. And as Jeremy mentioned, this is a NoSQL database, so there's not actually a schema other than the primary key. And here the primary key is a string of ID. And then some of the other fields we're using are species, which is a string, name, owner, age, and weight. On the right, you'll see an example of if you were to call getItem on one of these pets in the database, this is the way that the data might look. It's basically an associative array mapping the attribute name to the value. And the value also contains what type of data structure it is, so strings or numbers. So we know our criteria, and we have all this data, and we know that we need to pull out only a subset, but what option should we use? So DynamoDB actually provides two operations that allow you to pull out a subset of data. And these two operations are query and scan. And a query operation is generally faster than a scan in that it scans on the primary key, which is indexed, whereas a scan operation can scan on any attribute of a table, but it has an extra step in that it needs to filter out results at the end of its scan. So while query can only work on a primary key, scan can work on any key, and it's a little bit more flexible usually. But when you're designing your applications, definitely keep that in mind. And you need to figure out your use case, how you'll store the data, how you'll retrieve the data, and the different things you'll need to do whenever setting that up. So let's take a look at our scan filter criteria to try to determine which operation we should use. And as you can see, we're actually querying for 3 different attributes. We're querying for age, species, and weight. So in all these examples, it looks like we would initially use 5 scan operations, but actually we can combine 2 of these together because of some of the commonalities between them and some of the comparison operators that DynamoDB allows. So we can combine the puppies and kittens into a single scan operation by using the in comparison operator. So age is less than 1 and species is in cat or dog. And we can do the same thing with the older animals and then do a separate operation for the cats. So for each of these groupings, we'll create a scan iterator, because we can't use query because we're doing stuff other than the primary key. So we'll create a scan iterator and then iterate over each result and then add a record to the pet appointments table. So I've mentioned iterators a couple of times now, but I think it's important to cover what that means. Iterator is a design pattern that encapsulates the logic needed to continue seeking forward in a container's elements. And so this allows you to not need to care about the way that a resource is paginated. It handles markers, next tokens for services like S3 list objects. You don't need to know what a marker is. And for DynamoDB query or scan, you wouldn't need to know if a result set is truncated. It just yields that back to your for each. And all these iterators are built on top of Guzzle iterators, which are in turn built on top of SPL iterators. And SPL stands for the standard PHP library. And among other classes and interfaces, it provides a set of interfaces for iterators. So when you actually implement this, an SPL iterator, you can for each over one of these objects, almost like it was an array. So here's actually how iterators work in the new SDK. all iterators are seeded by a command object. So a scan iterator would be seeded by a scan command. And then you begin to, well, a command is basically an encapsulation of the parameters that are sent to an operation. So then that command knows how to serialize an HTTP request and then how to deserialize a response and give you some useful data. So all you do is you for each over your scan iterator. That's going to send the initial request. And for each item in that list of results, so for a scan, it's going to have multiple items in the result set. For each individual item, it'll be yielded back to your for each. And then we'll check, is the result set truncated? If it is, then you send subsequent requests and then yield those back to your for each until finally it's not truncated anymore in your loop. So here's a pretty simple example of issuing a list tables operation and iterating all of the paginated responses. So here you can see that we're calling the getIterator method on the DynamoDB client object. And this method, getIterator, is something provided to us by a Guzzle service client class. And because the SDK extends from the Guzzle service client, we get access to this helper method and some other helper methods. But what this is doing is it's actually creating an iterator object for us based on the command's name and returning that. So you can pass in the name of the operation you'd like to execute. Here we're passing in list tables. Or you can pass in an actual instantiated command object. And the getIterator method will know what to do based on that. And then the second argument, we're passing in parameters to that operation. So we're allowing the getIterator to actually do a factory type implementation to create the iterator and the operation. And this is passing in the parameters. And then once you have this object, all you do is for each over it. And you don't care if it sends 1 or 100 requests, but you just know that it's going to give you every single table in the result set. And here's a little bit more of an in-depth example that shows one of the scan iterators we just talked about. And this is showing the younger pets. And again, we're passing in the name scan, and then we're passing our parameters to the operation. We're interacting with the pets table, and this is the cats and dogs with the comparison operator of in. Because we're using scan, we have a little bit more flexible operators. And the age is less than 1. So because it's built on top of SPL, we can use some pretty cool SPL implementations like the append iterator. So I mentioned that we needed to use 3 iterators to get our entire result set of at-risk animals. Well, if we can encapsulate the logic of having to iterate over 3 iterators by using an append iterator. And what this basically does is it will exhaust the first iterator in the append iterator, then continue to the next, then the third, until it's exhausted every iterator in the collection. So all you do is append them to the append iterator, and then call for each over it, as if it were almost like an array. And you might notice that we're just echoing out the pet's name. And this is a little bit different from SDK1 in that SDK1 would return stuff like a simple XML element, whereas in SDK2, we are returning a model object, which acts sort of like an array, except that when you call keys that are missing, it's not going to give you a warning. So it's a little bit more helpful. And here we're just echoing out the pet name. So we're going to show you a quick demo of what it would look. So we're going to iterate over our at-risk pets and just show you data on each one. And you might see so you'll notice some pausing here as it iterates over each result set. That pausing is actually sending a subsequent request for you on your behalf. So that just iterated over all of the animals in a result set and showed their attributes. So you can take this even a step further. Oh, 1 second.
Yeah.
So you can take this a step further and use the event system. So because the SDK is built on the Symfony 2 event dispatcher, from almost every object, so the clients, commands, requests, you can attach an event listener to almost any object that owns an event dispatcher and modify behavior of these objects. So here we're showing how you can add a subscriber to a client object called the CommandAnnouncerListener. And you can implement an event subscriber. It's pretty simple. It's a pretty simple interface from the Symfony 2 event dispatcher. The only real method you need to implement is the getSubscribedEvents public static method. And what this does is it's going to return an associative array mapping the event that's emitted to the method on the object that you want to invoke when that event is encountered. So here we're saying when command.beforeSend is emitted from whatever this is attached to call the onCommandBeforeSend method of this object. So, and then the on command before send method receives an event object, which can contain event name and contextual information about the event. So like this is going to contain a command object. And you can just call event command get name. And we're going to show that same example, but we're going to actually echo out the name of each operation being executed before we do it. And we'll do a little sleep to better show that. So here you can see it's saying executing the scan operation, and it's pausing a little bit, and it's executing a follow-up scan operation. And that's actually being triggered by the command.onBeforeSend. So this received that event before it actually executed, did something with the event object, and returned back to the dispatcher. So you can implement your own custom business logic with event systems without having to subclass or do any additional work. All right, so now that we know our at-risk animals and we know how to iterate over and return that subset of data and how to get everything and add events to clients, let's talk about how you can efficiently push up these appointment records that we'll need to make to let owners know to bring their animals in.
So we're going to go ahead and build off of the example that Michael showed you to, like he said, put those items into DynamoDB instead of just displaying them. So DynamoDB has the put item operation. So we could, in theory, as we for each through the results of that scan iterator, issue a put item command for all those things. But we can also do it in a more efficient way. The DynamoDB API has a method called batch write item, which allows you to combine up to 25 put or delete item requests into one request. So that'll be a little bit more efficient. But we can do even better than that. There is a feature in the new SDK called the DynamoDB write request batch, which encapsulates the DynamoDB batch write item operation. I'm going to talk to you about the specifics of that in a second. But as Michael talked about earlier a little bit, and as I just mentioned now, there is a batch system built into the SDK and the underlying Guzzle library. The batch system allows you to batch, well, pretty much whatever you want. You can use it to create custom batch workflows. You can use it to create custom bulk item operations. The system is designed with a very loose coupled architecture. There's design patterns. You can inject custom logic. So I want to show you a couple of simplified UML diagrams to help you see kind of how it works. So at the core of the batch system is the batch object. Go figure, right? And the batch object has basically two important methods: the add method, where you add the items you are batching, and the flush method, which is responsible for doing something with those items. Now, the behavior of the flush method is determined by using the strategy pattern. You can inject two different strategies into your batch object. One is a batch divisor, one is a batch transfer. We have default implementations of those in the SDK and Guzzle. But you can also create your own to do your own custom logic. The batch divisor, the job of the batch divisor is to just take the items in your batch and group them into chunks that you're going to do something with. Then the batch transfer object is actually what defines the logic of what you're going to do. And that can be, like I said, anything you want. You could call web services, you could write to database tables, you could write to files, you could echo something, you could sleep for 1,000 seconds. It doesn't really matter what you're doing. You can do whatever you want. In the case of the DynamoDB write request batch object, that's where the logic happens, where we're going to take those individual put item requests, we're going to turn them into a single batch write item request and send that along. The batch system also has a series of decorators following the decorator pattern. Again, you can implement your own, but we have some provided in the SDK. One of those is the exception buffering decorator, which basically catches all exceptions that might be thrown during when you're running the flush method and gives them back to you as a collection of exceptions at the end so you can handle everything after all of your items have been processed. Another one is a notifying decorator, which simply allows you to register a callback to be executed every time the flush method is called. And another one is the flushing decorator, which allows you to set a threshold of a number of items such that when you add that many to your batch, it starts to do flushing for you, so you don't have to call it explicitly. And we're going to use that with the DynamoDB write request batch as well. To tie all these things together, there is a batch builder class, which simply makes it easier to use because it encapsulates the logic for instantiating all these objects. So that if you looked at this diagram and you're like, well, that's too many things, well, you really just need the batch builder. So like I said, the DynamoDB write request batch is an abstraction over the batch write item operation and is a special case of this batch system that I just showed you. During our testing, we found out that this is actually the fastest way you can send bulk put and delete requests to DynamoDB. It uses that flushing decorator so that every time you add 25 items to this batch, it'll start issuing those batch write item operations. And so it's very easy to use. And an interesting thing about the batch write item operation in DynamoDB is that it's a best effort operation. It's not atomic at all. So you can put up to 25 put requests in there, but it might not execute all of them. One of the main reasons that might happen is because you have exceeded your provision throughput capacity. So if you had maybe 15 write capacity units remaining for that period of time, that second, and you sent 25 items, you might get 10 back. It returns those items back to you in the response of the request in a key called unprocessed items. Normally, when you're just using that command straight up, you have to then manage getting those items, putting them back into another request, and sending it again. But the DynamoDB batch write request batch class that we include in the SDK handles all that for you, so you don't even have to worry about it. So this is going to build off the example with the scan iterators that Michael showed you. That variable on the second line, the at-risk pets, that's that resulting single iterator that Michael constructed with the append iterator and the 3 scan iterators. So keep that in mind. So the top of the code, we're going to instantiate the write request batch using the factory method. Then we can use that scan iterator and for each over those results. And we'll create a put item command with that pet data, plus we could add in more data, like in this case, I'm putting a date to kind of represent it being an appointment. And we just, instead of executing that command, we just add it to the batch. And because of that flushing decorator, as you add items to the batch, as it reaches 25, it's going to flush those automatically for you. And then at the end, we'll do one last flush, because if there's any leftover items, like if you didn't quite make it to 25 with that last batch, it'll clean up the rest and send everything out. And it's really that easy. And when something that's that easy, it kind of makes you smile, right? There's the monkey again. You know you like the monkey. So we're going to go ahead and show you, sure ahead.
Batch limit of 25, was that a Dynamo?
That's part of the Dynamo API, yeah. He's asking if the limit of 25 put items is a limitation of the SDK or DynamoDB. It's part of the DynamoDB API. So the class that we wrote enables you to kind of not worry about that, because you can just add as many as you want. So we're going to go ahead and take a look at a demo for that code that I just showed you. Builds upon the example that Michael showed you. So in here, we're going to see the same thing where it's going to print out the operations that it's doing. But instead of just saying scan operations, it's going to be intermingled with the batch write item operations. And we are almost done. Right, there we go. So what that code did, in conjunction with the code that Michael showed you, is that basically scanned through over 15,000 items in our table. That's what I seeded our test table with. It pulled out the ones that we needed using the 3 scan iterators, combined those together, we iterated over those, and created batches of these put items to send those and put them into our appointment table. And it really only took a few seconds. And it even took less time than what you saw here, because we injected sleep operations into the first 10 operations, so you could actually see the name of it before it disappeared. So with the class that we make, you can create a single put item command but it actually extracts that information and turns it into the batch command for you. So it's doing that under the hood where you don't see it actually creating the batches. Did that make sense? Does that answer your question?
Yeah, and the other question went back to the attempts you had where you were attending like less than 1 year inoculations. You had a couple of different criteria.
Right.
Is it more efficient to query Dynamo, with smaller result sets like that and append them?
When you're using the scan operation, you should try to do it in as few operations as possible, because when you do a scan, it actually looks at every single item in your table. So we use 3 operations because that's the minimum amount we could figure out with the available conditions to get all the information we needed. Good? Okay, cool, thanks. Oops. Here we go.
All right, so we've shown some of the new features of the new SDK. We showed the DynamoDB session handler. How when you scale up, this session handler is a centralized database that's not on the file system, so users won't be logged out. We showed how you can use scan iterators to grab a subset of data and to return these paginated results without you having to do them yourself. And we showed batching on how you can really efficiently send up thousands of requests as quickly as possible. So we've rewritten a lot of things on the SDK, and we think it's a much more powerful SDK, and it's going to help you to be a more productive developer. And we really appreciate you coming today, and we're eager to hear your feedback. There's a feedback form, evaluation form, so we'd really like it if you could fill that out. But now I'd like to open up for questions if anybody has any.